Okay, very good afternoon to all of you. This is Vipul, and we are discussing the second unit of DMGT, the lattices, under the label lattices. Now, yesterday in the previous session, we were discussing about the totally partial ordered set as well as totally ordered set. चलिए वहां से आगे जाते हैं and जल्दी से एक छोटा सा रिवीजन कर रहे हैं what is partial ordered set and what is totally ordered set. A partial ordered set is a relation which is, let's do the definition. Partial ordered set is a relation which is reflexive, antisymmetric, and transitive. That's it. Equivalence relation किसको बोलते हैं? Which relation is reflexive, symmetric, and transitive. If relation is reflexive, symmetric, and transitive, then it is equivalence relation. If relation is reflexive, antisymmetric, and transitive, then it will be known as a partial ordered set, माने कि कोशेट जिसको हम बोलते हैं, ठीक है। उसके बाद हमने सीखा था that it's totally ordered set, totally ordered set. Now, when we can say that one of the relation is totally ordered set, in the definition of totally ordered set, the definition rules begin from the partial ordered set. Is it? Let me tell you. Yes. Here's the definition. A partial ordered set is known as a totally ordered set, or we may use the word chain, if any two element, if you pick any of the two element of that particular set A, then it will be a comparable element. Now, what we mean by comparable element? Well, we can say that two elements are comparable if there is a relation between both that element. Whether if we are talking about A and B, I can say A and B are comparable if A is in relation with B or B is in relation with A. Okay. Then, under this particular definition, with this particular definition of comparable element, one of the partial ordered set will be known as a totally ordered set, मतलब कि टोशेट मतलब कि chain, if its every element, every two elements are comparable. That means if you're gonna pick any two element from the poset, and there exists a relation between both them, whether A to R, A to B, or B to A, we are good with that particular order. But there must be a relation between every two elements. Then that particular partial ordered set will be known as a totally ordered set. So there is a difference between coset and toset. Toset का और एक नाम है, that is chain. ठीक है. So last वाले सेशन में हमने यहाँ तक किया था. So यहाँ से आगे जाते हैं. Let's have some of the examples related to coset. Now I'm giving you the set n. Then set n is a set of all the natural numbers, and our relation is less than or equals to. Now we are looking to check whether it is toset or not. ये टोसेट है कि नहीं है, मतलब कि ये चेन है कि नहीं है, ऐसे देखना ये है. अब टोसेट के लिए क्या है? When we can say that one of the relation is toset, that it should be poset, वो poset होना चाहिए, and its every two elements are comparable. उसके हर दो एलिमेंट कंपेरेबल होने चाहिए. देन अब पोसेट के लिए भी चेक करना है. पोसेट के लिए क्या होना चाहिए? दैट रिलेशन मस्ट बी सिमेट्रिक, that relation must be reflexive, then after antisymmetric and transitive. वो reflexive होना चाहिए, antisymmetric होना चाहिए, transitive होना चाहिए, मतलब कि वो पोसेट है, और पोसेट होने के बाद उसके हर एक दो एलिमेंट, it must be comparable. Then and then we can say that particular relation is toset, is it? So let's check whether this particular is going to act as a toset or not. So we are talking about the set n. N is a set of all the natural numbers. All the positive integers will be there. 1, 2, 3, 4, 5, 6 up to infinite, is it? Now our relation is less than or equal. So if I'm going to pick first element 1, then 1 is relation with 1, surely, because 1 is less than or equals to 1. Similarly, 2 is less than or equals to 2. Similarly, 3 is less than or equals to 3. Similarly, 4 is less than or equals to 4. That particular less than or equals to relation is true for each and every positive integer. So I can say 1 is relation with 1, 2 is relation with 2, 3 is relation with 3. So each and every element from this particular set, any of the element, for every x belongs to n, x is in relation with x. So I can say that this is reflexive. Reflexive हो गया. चलिए. Now, once we are confirmed that is a reflexive relation, so we will be going for antisymmetricity. Let's check whether this particular relation less than or equals to is going to act as anti-symmetric or not. Yesterday we had to only yesterday we had checked that the anti-symmetric relation hai ye, because if you're going to pick 2 is less than equals to 3, yes, 2 is less than equals to 3, this is correct. So 3 is less than equals to 2 nahi hoga, it doesn't, will be not that, is it? So yes, if a is less than equals to b, then b is less than equals to a, ये नहीं होने वाला है, is it? So hello, hello, hello. Am I audible properly? Hello. I got some of the noise from your side, so it might be. Yes, एक बार unmute कर तो बेटा.
Yes, sir.
Proper संभलाइ से
बरोबर
मारो
है, sir. Continuous.
Okay. So yesterday we had checked that this is less than equals to relation is surely going to act as anti-symmetric relation. So yes, it is reflexive as well as anti-symmetricity. Now, if we check about transitivity on the less than equals to, then always we will get that, because we are dealing with the relation less than equals to. We know that 1 is less than equals to 2 and 2 is less than equals to 3. Then surely 1 is gonna less than equals to 3, is it? So yes, this relation is reflexive, antisymmetric, and transitive. Now, what we need to check? Now, once we are confirmed it is reflexive, antisymmetric, transitive, so I'm sure this particular is poset. अभी मैं बोल सकता हूँ कि ये poset है. But we are not checking for the poset, we are looking for the tosat, is it? We are looking for the chain, whether this is going to act as a chain or not. So क्या लगता है चलिए आपको? Surely will it gonna act as a tosat or not? Tosat होगा, हाँ या ना? Waiting for your reply. For the tosat, what you need to check, you need to determine that it's every 2 element are comparable. आप इसमें से n में से कोई भी 2 एलिमेंट ले लीजिए, उसका रिलेशन होना चाहिए, उन दोनों के बीच में रिलेशन होना चाहिए. सपोज वी नो दैट n is set of all positive integer 1 2 3 4 5 6, is it? Any 125 will be there, so many numbers will be there. If I'm going to pick 1 and 125, both this will be in relation, yes or no? Yes, it will be. This is correct. 1 is less than equals to 125. Even I can pick 126, 127. It's true. Sir, what will be the case if I'm picking 125 on the left hand side and 3 on the right hand side? So ये तो नहीं होगा. This is not true. But it's reverse. That 3 is less than equals to 125. It's correct, is it? So if you're gonna pick any of 2 elements from this particular set, then surely you will have one of the pair. Either if I'm gonna pick 1 with any of the element, 1 with 1, 1 with 2, 1 with 3, 1 with 4, 1 with 5, 1 with 6, 1 with 7, I'll have the relation. Similarly, if I'm gonna pick 2, 2 is having relation with 1. Not in this way, but 1 comma 2 is there, is it? So for 2, 3, 4, 5, 6, 7, all the numbers will be there in the relation with 2. So in that way, if you're gonna pick any two element, suppose I'm picking 47 and 64, then one of the inequality will always solve. 47 is less than equal to 64. So they are in the relation. I can write like this: 47 are 64. That means both these are comparable. So in that way, if you pick any two elements from the n, then surely they are comparable elements. So now we may conclude it is reflexive, it is antisymmetric, it is transitive. So that means it is tosat. Moreover, its every two elements are comparable, so it is tosat, and now it is posat, totally ordered set. Or I can say that it is a chain. So yes, it is a chain. Surely, let me show you the solution. कैसे लिखेंगे हम इसको? Let's go through it once. I'm giving you 1 minute. Just all of you are supposed to go through it. All those who are attending this will go through it and will reply on the chat box. Are we getting this? Are we getting this? You need to acknowledge on the chat box all those who are attending this. I'm having 37 in front of me and I need reply from all of you. This is very, very easy to understand. कोई बड़ी बात नहीं है, बहुत ही आसान है. बस आपको पूरी सीक्वेंस पता होनी चाहिए कि टो सेट के लिए पहले देखना है पोस्ट सेट का हर एक एलिमेंट अगर कंपेरेबल है देन that POSET will be known as a TOSET का और एक नाम है that is chain. So उसके लिए देखिए कहाँ से स्टार्ट हो रहा है. This begins with the set, then after Cartesian product, then after subset, relation के different types, symmetricity, reflexivity, transitivity, antisymmetricity, इन सबको मिला के कुछ नया बनाया जा रहा है. Is it? So this is the way we can define TOSET. One more example. Will you try this? S64B is chain or not chain? Whether I'm using the word chain or whether I'm using the word TOSET, both these are same. I can use the word chain or I can use the word TOSET, both these are literally same. Now, we are looking to identify whether this particular is going to act as a TOSET or not. S64, D. Now, S64 means the set of the divisor of 64. S64 means set of all the divisors of 64 and D means the relation divides. If I'm writing A dB, that means A divides B. It means A divides B. Is it? Like that. So let's quickly list out all the elements of 64. I need one of you to unmute yourself and let me know what are the elements of S64? Meghna, are you there? Okay, Raj Panjwani, are you there? Okay, Mohammed, are you there?
Yes, sir.
Yes, dear, please. List out S64.
1, 2, 4, 8, okay, 16, plus 32, and then 64.
Is it? 1, 2, 4, 8, 16, 32, 64. These all are the divisor, or we can say factors of 64. So this is our S64, this is our set. Now, we are checking this particular set with the relation divides, is it D, and we are looking, we are going to check whether this is going to act as a TOSET or not, that means totally or a set or not. So reflexivity dekhte chaliye pehle. Reflexivity, 1 divides 1, whether it is correct? Yes, it's correct. 2 divides 2, it's correct. 4 divides 4, it's correct. 8 divides 8, yes, it's correct. So each and every element of the set is having relation with itself. So yes, it is reflexive. Antisymmetric, second is antisymmetric. Now for antisymmetricity, we'll be picking two different elements. So for that, I need to check one is whether one is relation with 2. Yes, 1 divides 2, correct? It's correct. Is it 1 divides 2? It's correct. But it's reverse, that 2 divides 1. This is not that. Will be not present over there. Is it? So yes, if 1 divides 2 is that, there is no existence of 2 divides 1. 2 divides 4, this is correct, but the 4 divides 2 nahi hona chahiye na, nahi hoga, because 4 divides 2 is not correct, is it? 2 divides 4 is correct. Whether if we are having existence of 2 divides 4, then 4 divides 2 is not present there, good. So in that way, if you're going to pick any two element like that, those are in relation, then its reverse pair will be absent, surely. Its reverse pair will be absent. So yes, it is antisymmetric or even. And for transitivity, it is very, very simple. 2 divides 4, 4 divides 8, then surely 2 is going to divide with 2 divides 8, surely. Is it? So transitivity is also there. So this relation is reflexive, antisymmetric, transitive. That means it is POSET. POSET to ho chuka hai. It is POSET. Now, what we need to check yet? We are not looking for POSET. We are looking for TOSET. TOSET means chain. Is it? So we need to determine every two element. If you're going to pick any two element from this particular set, there must be in relation. If we can determine that, then surely baat khatam. This particular POSET will be converted into TOSET. So क्या लगता है? चलिए I'm giving you 1 minute. Let me know क्या लगता है आपको, ये TOSET होगा कि नहीं होगा? ये TOSET होगा कि नहीं होगा? आपको बताना है जल्दी से, जितनी जल्दी हो सके. You may drop your message on the chat box. Even I will be going through chat box. Let me go through the chat box. Okay, many of you are saying it's gonna act as a TOSET. Yes, you are correct. Surely it's gonna act as a TOSET. Let me show you how. Because if you're gonna pick any two element, one divides 4, one divides 8, one divides 16, one divides 32, one divides 64. 4 divides 16, 4 divides 32, 4 divides 64. This particular set as 64 under the relation divides is surely gonna act as a TOSET. It's gonna act as a chain. But अगर लिखना है, if we are supposed to present it, कैसे करेंगे? It should be like this. Go through it. The presentation should be like this. Like this. एक बार देखिए, पूरा देखिए शांति से, बताइए मुझे समझ में आ रहा है नहीं आ रहा. Okay, the bullets are not properly visible here. Is it? I need to change the bullets. I will change it. Okay, but अभी के लिए ऐसे रखे. So these are the story related to POSET and TOSET. Now, once we are good with the POSET as well as TOSET, we may move for the hash diagram. अब इसका hash diagram कैसे बनता है, चलिए वो सीखेंगे. But yet I am giving you 1 minute. देख लीजिए, किसी को अगर डाउट है कुछ भी, drop comment on the chat box. I will be going through that particular comment. And if we are not having any query, any doubt, then we'll be switching over to the hash diagram. So I'm waiting for your reply quickly. All those who are attending this will drop message on the chat box whether he or she is comfortable with this content or not. Quickly. So almost all of you are good with this. कोई query नहीं है मेरे पास. So let's move further. एक दो questions मैंने रखा है आपके लिए. You may check at your time whether this is TOSET or not. ठीक है? Now hash diagram. How we can draw the hash diagram of the TOSET. So let me make you understand about that. But before going for the hash diagram, I need to give you a concept of the cover of an element. Then I can say that one of the element is cover of the other element. Is it one of the element is cover of other element? Suppose if I'm dealing with one of the set like this, A, I'm having a set A 1, 2, 3 with the elements 1, 2, 3, then 2 is going to act as a cover of 3 or 1 is going to act as a cover of 2. ये कैसे decide करेंगे? तो चलिए पहले ये एक बार clear करते हैं, and then we will be moving for the hash diagram. So what is it? What we mean by cover of an element? Let one of the poset with us, A R be a poset. Now poset means partial ordered set. Take care, partial ordered set. I'm not talking about the poset. I'm talking about poset. AR is in poset where A is one of the set and R is the relation. Now, for element AB belongs to A, where both elements are different. B is called cover of A if B is gonna call cover of A. I will be saying B is cover of element A if A R B, if A's relation with B, but there is no C belongs to A such that A का C और C का B के साथ relation. Okay, then I can say that B is cover of A if A is having relation with B and इसके बीच में कोई वो ट्रांजिटिविटी वाला रिलेशन नहीं होना चाहिए, कोई ऐसा एलिमेंट नहीं मिलना चाहिए. दैट must not C exist in the set such a way that A are C and C are B. So ऐसा कोई एलिमेंट C का अगर existence नहीं है, if we are not able to identify any such C from the set A, then I can say that B is cover of A, and B is known as a cover of element A. That's it. Okay. For example, देखिए यहाँ पे S18. We all are good with the S18. S18 will contain the element 1, 2, 3, 6, 9, 18. Is it? And the relation is divides. Division is that particular relation which I'm talking right now is divides. We all know that this is a poset. We had already checked S18, D is a poset in our previous session. Now, elements and cover. It's cover. Okay. Tell you 1. If I'm talking about 1, then 1 is having two covers, 2 and 3, because 1 is in relation with 2, is it? Even 1 is in relation with 3. Even 1 is in relation with 6. Even 1 is in relation with 9. Even 1 is in relation with 18. But observe here. I cannot say 6 is cover of 1. I cannot say 9 is cover of 1. I cannot say 18 is cover of 1. Why? Because for these 3 elements, I'm having if I talk about 1 R 6, then I'm having one of the element like this, 1 R 2 and 2 R 6. 2 R 6 is it? Right now that particular relation is division. That particular relation is division. So better if it will be better if I'm writing like this. It will be better if I'm writing like this. 1 is relation 1 divides 1, even 1 divides 2, even 1 divides 3, even 1 divides 6, 1 divides 9, 1 divides 18. Is it? All these are correct. But yet, what I say, the cover of 1 is only 2 and 3. I cannot say 6 is cover of 1. I cannot say 9 is cover of 1. I cannot say 18 is cover of 1. Why? Because for this one, 1d6, 1 divides 6, but I'm having one of the element which I can fit in between both of that, 1 and 6, like this. 1 divides 2 and 2 divides 6. Is it? There is the existence of one of the element. Those are acting as those are following the transitivity relation between 1 and 6. So 6 is not the cover of 1. Similarly, for 9, I can have 3. 1 divides 3 and 3 divides 9. So there is an existence of 3 in between 1 and 9. So I cannot say 9 is cover of 1. Similarly, for 18, I can use 9. 1 divides 9, 9 divides 6, 9 divides 18, or I may use 61, 1 divides 6, and 6 divides 18, is it? So the cover of 1, there are 2 different elements. Those are going to act as a cover of 1. 2 and 3, because for 2 and 3 I will not able to set any of the element in between 1 and 2. I will not able to set any of the element between 1 and 3. Is it following that particular transitivity relation? So the cover of 1 will be 2 and 3. Now, will you tell me what will be the cover of 2? Are you in position to let me know what will be the cover of 2? कौन बताएगा मुझे 2 का कवर क्या होगा? What will be the cover of 2? It will be good if one of you will unmute yourself and let me know. What will be the cover of 2? What will be the cover of 2? You should unmute yourself, let me know, or you may reply on the chat box even. Which element is gonna act as a cover of 2? Emma, Janvi, Nikita, am I properly audible? Rishabh, Meghna. 2 का कवर क्या होगा बेटा? Yes is saying 9. Cover of 2 will be 9. First of all, let me know 2 divides 9, whether it is correct or not. Yes, whether it is.
Sir, 18.
Sorry?
18.
18. 2 divides 18. I can set, can I set any of such element 2 divides 6 and 6 divide 18? Is it correct or not?
Yes, it is correct. But in case of 18, there will be not any another element.
So, but here it
18
is.
can't divide anything.
2 divides 6, 6 divides 18. We are having one of the intermediate element between 2 and 18. So I cannot say 18 is the element. 18 is the cover of 2. 2 का cover 18 तो कैसे होगा बेटा?
Okay.
What about 6? 2 divides 6. This is correct, is it? Do we have any such element between 2 and 6 that's gonna follow the transitivity relation? एक ही देखती हैं. Now 2 divides 3 is not correct. 3 divides 6 is correct, but 2 divides 3 is not correct, is it? So according to me, the cover of 2 will be 6. Is it? Getting yes or not? समझ में आ रहा है यश कि नहीं आ रहा है बेटा?
Yes, sir. Yes, sir.
Good.
It should not have any kind of intermediate element.
Yes, yes, there you are. And these are the list of the rest. Check. I'm giving you 2 minutes. Kindly check. The cover of 3 will be 6 and 9. Cover of 6 will be 18. Cover of 9 will be 18. So look, you need to observe so many things over here. It is not like that कि कोई एक element का cover एक ही होता है ना. We may have more than one covers for one element. Even if you observe then 18 is cover of 6, even 18 is cover of 9. Is it? 6 is cover of 2 as well as 6 is cover of 3. Is it? So it's totally possible that one of the element is having more than one cover, or one of the cover is gonna कोई एक element है वो एक से ज़्यादा लोगों का भी cover हो सकता है. Is it? So we need to observe all that things. So kindly go through this. And there will be no existence of cover of 18 in the this example. Okay? So let me know कितनों को समझ में आ रहा है. अब यहाँ से हम सीखेंगे once we are good with the cover, then we can easily move for the hash diagram. But before that, the concept of cover must be clear in your mind. Are we good with this? Are we good with this? Hopefully. Here the relation is, I forgot to give the relation. Relation is subset. So there is an issue with the, yes, here you can see. Here you can see. Yes, મારી આખી સ્ક્રીન દેખાય છે ને ફરી દીજો તો બેટા.
હા
Yes.
એટલે હા હા ના હવે કઈક અચ્છા
હા,
એટલે
હા.
આ સ્ક્રીનમાં જતું છે કે
એમાં છે ને ઇશ્યુ છે
ફૂલ સ્ક્રીન
P of A and relation is subset. This is my set. This is the relation P of A. We all know that what is P of A? P of A is a power set of set A. Power set of set A. If we're gonna list out power set of set A, then it will be set A itself, null set, then after singleton set 1, singleton set 2, singleton set 3. After that, 1, 2, 2, 3, and 1, 3. These are all the possible subsets of set A. And if I'm going to form one of the new set of all the possible subset of set A, then that particular known as a power set. So this is my set P of A for this particular, and relation is subset. So A is subset of A, yes, it is correct. Null set is subset of itself, it is correct, is it? So ये तो poset तो होगा ही होगा, surely. That is reflexive as well as antisymmetric as well as transitive. ये तीनों तो होगा ही होगा. Now, अब यहाँ पे हम cover देख रहे हैं. What will be the cover of null set? The cover of null set will be 1, 2, and 3, because we will not able to set any elements between them. Null set is a subset of singleton set 1. Null set is actually a subset of all of this, is it? But once null set is subset of singleton set 1, I can say that this particular is gonna act as a cover of this, because I'm not able to set any such other subsets between this. I'm not able to set any of the other intermediate element between this, is it? If we look about this, even null set is subset of 1 and 2, but I can't say that 1 comma 2, this particular set is gonna act as a cover of this, because I can set intermediate set like this. 1 null set is subset of 1 and 1 is subset of 1 comma 2. So that is the reason I cannot say 1 comma 2 is a cover of 5. Similarly, I cannot say 2 comma 3 is a cover of 5. I cannot say 1 comma 3 is a cover of 5. Even I cannot say A is cover of 5. So with this particular logic, these are the list of all the covers of the element. Observe. These are all the elements of power set of set A, is it? And these are the list of their respective covers. जैसे नल सेट का कवर है 1 2 3, 1 का कवर है 1 2 1 3, 2 का कवर होगा 1 2 2 3, 3 का कवर ये दो, इन तीनों का कवर सेम है, that is the entire set A. So using both these examples, one can easily get the concept related to cover of an element. Now finally I'm asking whether is there any doubt related to cover of an element in the POSET? Do we have any query, any doubt in the cover of the element? Good. Rishabh is replying properly. Thank you, Rishabh. What about others? I'm having 39 in front of me and I'm getting a single reply. I'm having 39 students in front of me. All of you are supposed to reply whether we all see means you are clear with the concept related to cover of an element or not? Good. Let's move further. Hash diagram. These are the three interesting characteristics. Based on that, we will be drawing one of the diagram, and the diagram will be known as a hash diagram. Let me help you to read this. Hash diagram is a graphically representation of POSET. Mark my word, this is a graphical representation of POSET, partial ordered set. POSET elements, okay? Now, each element of POSET is represented by a dot and joined by lines according to the following rules. We'll be representing each of the element with the dot like this anywhere, as it will be joining them with some of the with straight line. But when I can join both these elements, how I can join both these elements, there must be some of the precise rule, is it? So what are that rule? That rules are, there's three. If B is cover of A, then dot corresponding to A appears below in the diagram than the dot corresponding to B. If B is the cover of A, if B is gonna act as a cover of element A, then A appears below in the hash diagram than the dot corresponding to B. This is the first rule. Second, the two elements A and B are connected by line segment if either A is cover of B or B is cover of A. If we are joining two dots like this, then surely if this is A, this is B, then either B is gonna act as a cover of A or A is gonna act as a cover of B. Then you can join both that lines. This is the rule number 2. And third, it's upward orientation diagram. It is actually upward orientation diagram, is it? So based on this three rule, we can first one, if B is cover of A, then A appears below in the diagram than the B. A appears below than B. And second, you can join two elements if they are cover of one of them, each of them. Is it? So basically both these are the rules. And using this, let me show you one of the hash diagram. And then I will ask one of you to explain this. This is one of the POSET. We all are knowing that S18, D is a POSET. S18, we are having this element 1, 2, 3, 6, 9, 18. Now here, before moving for the hash diagram, we must have a list of cover of elements, then we may go for the hash diagram. So hash diagram do करने से पहले आपके पास ये वाला लिस्ट होना चाहिए हर एक एलिमेंट का कवर आपको बताना चाहिए the cover of 1 is 2 and 3, cover of 2 is 6, like that. Is it? Whether you are dealing with any of the POSET, before moving for the hash diagram, before going for the hash diagram, you must have the list of cover of all the elements. Now, once you are good, observe this. Now, let me know whether you are able to get this or not. This is hash diagram for this particular. देखिए सबसे पहले मैं नीचे से स्टार्ट करूंगा. As I said that it is upward orientation diagram. I will start from the bottom. One is here. Now, the cover of 1. We are having two covers, 2 and 3. So 2 and 3 must be a little bit above than 1. 2 and 3. यहाँ पे मैं 1 लिख रहा हूँ. 2 and 3 must be a little bit upwards than the 1. Let me draw 2. Let me represent 3 over here. Now I need to connect them because 2 is cover of 1 as well as 3 is cover of 1. Now then I will move for the 2. 2 का cover क्या है? 6 है. Cover of 2 is 6. Even cover of 3 is also 6. That's it. So 6 must be upwards than 2 and 3. 6 का level जो है 2, 3 से ऊपर होना चाहिए. It is not like that कि आप यहीं पे represent करो. You may represent over here. We are good. This is 6. Now 6 is cover of 2. Even 6 is cover of 3. Then moving further with the similar rule for the 6. Okay, yet we are pending with 3 का और एक cover है 9. Now I'm not that much sure whether 9 is cover of anyone other or not. So I'm putting 9 over there. This is 9. So let me connect this like this because 3 is also having cover. 9 is it. Then after for 6, 18 is the cover. For 6, 18 is the cover. So 18 must be over there. This is 18 and 18 is also cover of 9. So I must connect like this. So this is also valid as diagram. This is also valid. This is also valid. This is also valid. So this is the way you can draw a diagram. Orientation, its orientation will be always upwards. तो सबसे नीचे वाला एलिमेंट ये रहेगा, ठीक है. एंड देन जैसे ही उसके कवर मिल रहे वो आपको ऊपर 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 उसके एक लेवल ऊपर 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 लिए रिप्रेजेंट करना, ठीक है. आर वी गुड विद दिस? बताइए. वेटिंग फॉर योर रिप्लाई, वेटिंग फॉर योर रिप्लाई. देख लीजिए एक बार, कोई बात नहीं. दे आर नॉट इन एनी काइंड ऑफ हरी. If you're good, you need to acknowledge on the chat box. If you're good, you need to acknowledge on the chat box. All of you are requested to acknowledge on the chat box, please. I'm just getting 3-4 replies, that's all. कितनों को क्लियर है प्लीज रिप्लाई कीजिए चैट बॉक्स में. बताइए मुझे समझ में आ रहा है नहीं आ रहा है. इरशाद, मोहम्मद, good. Give you one more example, then we will stop over here. Here the set, let me वो पता नहीं क्यों नहीं आ रहा है. ये एनिमेशन में कुछ प्रॉब्लम है. The set is power set of set A with the relation subset. You just check. This is a power set, ये हमको पता है, and these are the list of all the covers of each and every element. Now if you wish to go for its hash diagram, अगर इसकी hash diagram ड्रॉ करनी है तो देखिए कुछ ऐसी होगी. देख लीजिए एक बार. 1 के 3 कवर, null set के 3 कवर है 1, 2 and 3. It should be one level up than 5. Then for 1 we are having 2 cover 1, 2 and 1, 3. For 3 we are having 2 cover 1, 3 and 2, 3. That it must be upwards than 3 and 2. And similarly we are having 2 covers for 2. Is it? And finally for 1, 2, 1, 3 and 2, 3 we are having a single cover, that is entire set A, 1, 2, 3. So this is the hash diagram for the POR set P of A subset. One more. Is it? So I had already shared this PPT with all of you. So you may go through this. This is very, very easy. कोई बड़ी बात नहीं है. You just need to have 2 basic rules that किसी का भी cover है उसके ऊपर represent करना है. इसको join कब कर सकते हैं? When you can connect 2 elements. Here I cannot connect. Here I cannot connect 4 and 6 because 4 is not the cover of 6. 6 is not the cover of 4. I cannot connect 4 and 28, 24 because 24 is not going to act as a cover of 4. So I cannot connect 72 with 12 because 72 is not the cover of 12, or even 12 is not the cover of 72, is it? So we just need to follow 2 basic rules, and you can easily draw the hash diagram of any of the POR set, any of the partially ordered set. So it's already 3, I think, yes, 2:57. So first of all, I will, before ending this, before we end this particular session, I will request all of you to drop your enrollment number on the chat box for the attendance purpose. Kindly drop your enrollment number on the chat box for the attendance purpose quickly. All those who are attending this will drop their enrollment number on the chat box quickly. Good. Thank you. Let me stop the recording.